Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, we have already discussed three cases in principal stress and strain. So, in this case, we will discuss where in case of any member, there will be presence of biaxial stresses. So, the forces will Px, Py and due to the shear stress, there will be Q1 and Q2. So, now our work is to find out normal stress and tangential stress. Okay. So, how to find out normal stress and tangential stress? Let's just cut this section into this part. And if we just take the name as here A, B, C, D and we cut the section with C, E. Okay. So, if we just cut the section, there will be easy to find out the tangential stress and normal stress. Okay. So, now we have the B, C, E triangular section. In this section, here one thing you can remember, okay, when we just cut this section, we are cut with it with here. We take this angle as theta. So, for this perpendicular, we will have here what? 90 minus theta, right? So, also as this is the theta, here we will have 1 theta. Okay. So, this C angle is theta, right? And we are having the Px at here and Py is at here. There will be normal stress, that is Pn, and the tangential stress will be Pt. Actually, these are the forces acting. For the stress is sigma n, and due to sigma n we are having here Pn. Like that, we are having Pt here for tangential stress. Okay. So, to find out Pn and Pt. Okay. So, what is the procedure to find out Pn and Pt? So, as we can see here, Q1 and Q2 are acting like in this direction. Okay. So, let's just draw the free body diagram of this triangular section. Okay. So, in this BCE triangular section, here the angle is theta. Okay. So, we are having Px here and Py here. While we cut the section, there will be lots of stresses, right? So, we just take one resultant stress and name that as Pn, right? Okay. It will act here in this direction. Okay. Also, we have shear stresses. The forces for that is Q1 and Q2. And if we just find out the tangential stress, that will be Pt. The force will be Pt. Okay. So, now our work is to find out, let's find out components of the sections. Okay. Here we have what? 90 minus theta. Okay. If we just cut this section into this, right? As this is the 90 minus theta, here we will have theta. Again here we will have 90 minus theta. Like that, so that you will have theta here. Okay. Okay. Here we have here theta and here 90 minus theta. As we have having theta here, then we will have here 90 minus theta, right? Again, as it is 90 minus theta, then here we will have let's cut this section into like this way. Okay. In this way, we will have the angles. So, our main aim to find out the components of four forces. These are like Px, Py, Q1, Q2. Okay. So, first let's take Py, right? Py will have two components in these directions, right? So, as per the angles here, we will have Py cos theta and here we will have Py sin theta. So, now we have two components of Py. Okay. Next, let's come to Px. So, here we will have Px cos theta and here Px sin theta, right? Now, components for Q1 and Q2. So, for the Q1, one will act like this and another will be here. Okay, and similarly for Q2, we will have one in this direction and another one will be in this direction, right? So, for Q2, we will have here what? Q2 cos theta and here Q2 sin theta. Okay. Similarly, due to Q1, here we will have Q1 cos theta and here Q1 sin theta. Okay. Let's just make it boxes so that we will never be confused. Okay. So, we have the components here. Now, our work is to find out which forces are acting along which stress, which forces. Okay, our main aim is to find out along PN, the forces acting along PN and forces acting along PT. So, how can we know that which forces are acting along PN? So, here you can see PN is acting like this. If we just draw the direction, so in this direction, okay, the forces which are acting in this way, those are components of what? Along PN. So, you can see here PY. Okay, this PY sin theta is acting along PN, right? Similarly, here you can see this is acting along PN and here you can see this is completely what? Along PT. So, we will take this one. Okay. We have three. One for Q1. You can see this one. Okay. So, now we have four forces P for PN. Now, the remainings are for PT. So, in case of normal stresses, it is easy. Okay. So, let's find out normal stress. Okay. Normal stress is what? Normal stress is nothing but sigma n, and the formula for sigma n is Pn upon area. Area of which area? Okay. So, here, if we just draw the 3 dimension of this triangle, okay, you can see here this plane is what? B, sorry, here you have C and B, here E. So, this BC plane is for Px, force Px, right? Similarly, here this EC plane is for Pn force. Okay. So, we can write area of EC. Okay. Now, how to find out the area of EC? Wait. Here, let's take the thickness is equals to 1. Okay. If we just put the thickness as unity, then our area will be EC only. Okay. So, here. So, for Pn, what we will write? So, for Pn, we can write components of Px, Py, Q1 and Q2 along which? Along Pn. Okay. Also, for area of SC, we can write EC. Next what? We have the components. Okay. So, let's just put the components here. This one and this one. Px cos theta plus Py sin theta. Upon EC plus, so for Q1 sin theta and here Q2 cos theta. Upon EC. So, here one thing you can see that this complete half equation is from case 2, right? We have already solved the case 2 and in case 2 we have this equation, and here this is your what? Equation of case 3. Okay. We can solve it here again just for the better understanding. Okay. So, for better understanding, we need to draw the triangle again B, C and E. Okay. Let's find out the stresses. Stresses will act due to the force Px, Py and Q1, Q2. Okay. So, as I have already said here, in case of this 3D diagram, so we have the formula for stress, that is force upon area, but here we have force as Px. So, the formula will become sigma into area, right? So, sigma into which area? Px will act in this plane. So, Px into BC we can write. Okay. So, the stresses, sigma x will be Px into Pc, sigma y will be Py into Pe, Q1. You can see Q1 is acting in BC plane. So, Q1 is acting along the plane. So, we will take the shear stress. Okay. Tau into BC and Q2 as tau into this BE. Okay. We have all the four stresses here. Now, in case of, sorry, let's put this as sigma and this as P. Okay. Here, bus. So, in case of Px, we can write sigma x into Bc cos theta upon EC plus sigma y into BE sin theta upon EC. For Q1, we have here tau BC into sin theta upon EC plus tau BE cos theta upon EC. So, let's move to trigonometry for some time. Okay, here if theta will be here, we know this is the base and perpendicular, and here we have the hypotenuse. So, we know, let's name it. Okay. So, we can say BC upon EC. Okay, this is the BC and EC, that is P by H. P by H is nothing but cos theta, and if we multiply cos theta with cos theta, we will have cos square theta plus sigma y BE upon EC, base upon hypotenuse, sigma y sin square theta. Okay. Now, what? This one. BC upon, again BC upon EC. Okay. Tau cos theta into sin theta plus tau sin theta into cos theta. So, if this and this will be add, so we will have 2 tau cos theta into sin theta. Okay. So, here we will have 2 tau sin theta into cos theta. Okay. So, here sigma x cos square theta plus sigma y sin square theta, let's name it as for formula of cos 2 theta. So, here in case of cos square theta, we can write 1 plus cos 2 theta upon 2, and here in case of sin square theta, we can write 1 minus cos 2 theta upon what? 2. Sigma x into 1 plus cos 2 theta upon 2 plus sigma y 1 minus cos 2 theta upon 2. Okay. So, this sigma n will be, we can write it sigma x by 2 plus sigma x cos 2 theta by 2 plus sigma y by 2 minus sigma y cos 2 theta by 2. Okay. If we just take these two this side, 2 sin theta into cos theta is nothing but sin 2 theta. So we will have here tau into sin 2 theta. Okay. Now, if we just beautify this thing, okay, so we can write sigma x plus sigma y upon 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau sin 2 theta. Okay. Now we have the equation for sigma n, right? So, also we need to find out the tangential stress. Now, let's just change the color, okay, to find out the tangential stress sigma t, or else you can write tau. It's visible. Find out sigma t. What do we need? For sigma t, we will need Pt upon area. Pt, if you remember, Pt is also acting at the plane of which plane? EC. Okay. You can see it is acting at EC plane. Okay. So for Pt, we can write components of Px, Py, Q1 and Q2 along Pt upon EC. Okay. Why EC? I have already said in case of find out sigma n. Okay. So components of what? Px, Py, Q1, Q2 along Pt. So we have already found out the components. Sigma t will be, let's just write directly from this. Okay, so which are the components? Here Py cos theta, and in this direction we are having Px sin theta. Okay, so here you can see this is acting this direction and this is acting in this direction. One is here and another is here. So we can take this as positive and in this direction as negative. Okay, so we can write Px sin theta minus Py cos theta. Okay, again here we are taking this direction as positive. So this Q2 sin theta will be positive and this Q1 cos theta will be negative. Okay, for better understanding, let's take one direction as positive. I have taken here this direction. Okay, you can cross check with by taking this direction as positive and just comment me in this video what you find out in last after solving the equation. Okay, I am taking this as positive. Okay, q2 sin theta and q1 cos theta. Plus q2 sin theta minus q1 cos theta. In form of sigma, we have already found out. Here also you can see Px is as Px is acting here, you can take the BC here. Okay. So sigma x into BC sin theta upon EC plus minus sigma y into BE cos theta upon EC plus for Q2 we can write tau into BC sin theta upon EC minus tau into BE cos theta upon EC. Okay, so let's just solve by trigonometry. We have already solved these things, so I will write it only BC upon EC. Sigma x cos theta into sin theta minus sigma y cos theta into sin theta plus tau, okay, BC upon EC, tau into theta into sin theta minus what? Tau into also cos theta into sin theta. Okay. Yeah. So we will have here this as sigma x minus sigma y cos theta into sin theta, okay, plus, so here will be okay, let's see here what we have. Okay, so we can write sigma t as sigma x minus sigma y. Let's just divide 1 2 and multiply 1 2 here, and now we will have this sigma t as sigma x minus sigma y upon 2 into sin 2 theta. Okay. So here we have the tangential stress and what? And the normal stress. So in this class we have discussed the both case 2, case 3 and case 4. If you have not visited the case 2, case 3, then you can see it here. Okay. So here if you just want to take the screenshot of this page, you can take, but because these components are very much important for the for finding out the normal stress and tangential stress. Okay. So we have already found out normal stress and tangential stress. In our next class we will find out how to find out the maximum shear stress and maximum principal stresses. Okay. So, to know how to find out the maximum stresses, you need to stay tuned with our channel. So, just subscribe and keep smiling. Thank you.